Variable capacity heat pump. The reference to be used for this verification is the Residential Alternative Calculation Method Variable Capacity Heat Pump Modeling Approach number TN #234449. It can be found at the following address. This training will be broken up into 4 different sections. First, we'll talk about the background. Then we'll talk about the performance compliance option eligibility requirements. Third is the verification protocols, and last we'll look at the forms. Variable capacity heat pump systems, or VCHP systems, are an emerging technology in California and the rest of North America, even though they are common in many other parts of the world. Prior research in North America has focused primarily on the technology's heating mode, while cooling mode energy performance and peak demand are important concerns in California. VCHP systems with very high seasonal energy efficiency ratio and heating seasonal performance factor ratings based on current test methods are currently available. However, these VCHP systems are not currently credited with improved energy performance in the California Title 24 building standards due to uncertainty regarding their installed performance. The VCHP credit has certain eligibility requirements that must be met. These do differ between ducted and ductless systems, and we'll take a look at both. Let's start by looking at those requirements that are applicable to both ducted and ductless VCHP systems. First, the system must supply conditioned air to all rooms. The indoor units must be located entirely in conditioned space. You're going to have wall-mounted thermostats in zones less than 150 square feet. And then you're going to have HERS verified refrigerant charge. Now, typically you would expect to have verification for airflow and fan efficacy as well, but compliance with those requirements is not required for this VCHP credit. So now let's look at those additional requirements that are applicable only to ducted VCHP indoor units. So first we have HERS verified ducts entirely in conditioned space, a certification of non-continuous default fan operation. This is for an optional fan energy credit. It is not HERS verified. And then we do have a HERS verification of non-continuous fan operation, which again is an optional credit. So you may or may not see these. Only one of them is HERS verified. Next, we have certification of low static VCHP systems. HERS verification of low static VCHP certification listing, HERS verification of indoor unit 350 CFM per ton airflow, and HERS verification of air filter sizing for ducted indoor units. Now this is ducted low static VCHP systems with any length of duct shall comply with the air filter requirements, and system air filters shall have a clean filter pressure drop less than or equal to 0.1 inches of water column. When a performance certificate of compliance indicates a space conditioning system requires verification of the variable capacity heat pump compliance option eligibility requirements, the installed VCHP system shall be field verified to confirm compliance with the eligibility requirements as specified in this section. So we just talked about all of the requirements, the eligibility requirements. We saw that some of them were listed as HERS verified, others were not. So now we're going to go through those verification protocols for the HERS verified options. Low static system certification for ducted systems. The manufacturer of ducted indoor units shall certify to the Energy Commission that the system is a VCHP that meets the definition of a low static system. The manufacturer's model number or numbers shall be included in listings of certified to the Energy Commission low static pressure VCHP systems, which will be published on the Energy Commission's website. The list of approved equipment can be found at the following link. So the list does consist of an Excel spreadsheet, and it's going to list make, model, numbers, manufacturing names, and then whether or not that unit complies with the fan continuously operating by default. So you'll be using this for a couple of different verifications, but this one is very similar to the list that you'll see when doing low leakage air handlers. Very similar. You'll open up that list, make sure that you always get a fresh list when you're doing that verification, as items can be added to it. And you're going to look for the make model numbers of the VCHP that you're trying to verify and ensure that it is on this list. Non-continuous default fan operation certification for ducted systems. The manufacturer may elect to certify to the Energy Commission that their ducted indoor unit plus outdoor unit combination does not operate the indoor unit fan continuously by default. This certification is required in order to receive credit for the non-continuous fan operation component of the VCHP compliance option credit. If the installed VCHP system has ducted indoor units and the certificate of compliance indicates credit has been taken for non-continuous default fan operation, then visual inspection of the Energy Commission listings of certified VCHP systems shall confirm the installed system is included in the Energy Commission listings and the certification indicates the system is a type with indoor units that do not run the fan continuously during periods when there is no call for conditioning. You will use the same list that you used for the low static certification to verify that this system does not operate the fan continuously by default. So you can see we've got that column there highlighted in red. And so what you'll do is you'll look up the indoor and outdoor unit on this list, and it will either indicate a yes or a no as to whether or not it operates that fan continuously by default. So what you want, since it's a non-continuous is what you're looking for, you want to make sure that that has an answer of no. Refrigerant charge verification. The installed system shall have refrigerant charge verified in accordance with applicable procedures in RA 3.2. Because these types of systems cannot be verified using the standard charge procedure, the weigh-in method must be used. So these are the same requirements that you follow for any standard refrigerant charge verification. There's nothing special here in regards to this being for the VCHP verification. Low leakage ducts located entirely in conditioned space verification. Ducted indoor units shall be verified in accordance with the verified low leakage ducts in conditioned space procedure in section RA 31438. So again, just like refrigerant charge, this one also is just your standard low leakage ducts and conditioned space verification that you would do on a standard home. Nothing special here for the VCHP credit. Ductless space conditioning system indoor units located entirely in conditioned space verification. Now this one sounds very much like the one we just covered. That was ducted units, duct systems in conditioned space. This one is just the ductless space conditioning system indoor unit. So that indoor coil, fan coil, air handler, whatever it happens to be, that is going to need to be located entirely in conditioned space. Now this one is unique to the VCHP credit, and you'll note that it is a unique verification if it is found in the SC section that we see listed here. So this particular one is SC 31418, and all of these SC sections can be found in that reference document we talked about at the beginning of this training. So a visual inspection shall confirm that ductless indoor units are located entirely in conditioned space in accordance with the following requirements. Ductless indoor unit types that mount entirely on the interior surface of the dwelling unit walls, ceilings, or floors shall be considered to be entirely in conditioned space. Penetrations in the wall, ceiling, or floor surface necessary for the indoor unit refrigerant piping, condensate drain, or electrical connections shall be allowed, provided the penetrations are well sealed. Ductless indoor units that penetrate the interior surface of dwelling unit walls, ceilings, or floors and protrude through cutout openings in the dwelling unit walls, ceilings, or floors shall be inspected to determine whether the indoor unit is installed inside both the thermal boundary and the air barrier of the dwelling as follows. If the ductless indoor unit protrudes through the air barrier into unconditioned spaces, such as attics, crawl spaces, garages, or outdoors, the indoor unit shall not be considered to be located entirely in conditioned space. If the indoor unit protrudes into indirectly conditioned spaces, such as drop ceilings or floor assemblies in a single-family or multifamily, multi-story building that are wholly inside both the thermal boundary and the air barrier of the dwelling, then the unit shall be considered to be located entirely in conditioned space. Verification at an early stage of building construction may be necessary in order for this visual verification to be possible. Space conditioning system airflow supply to all habitable spaces. And this can be found in SC 31417. A visual inspection shall confirm that all habitable spaces in the dwelling unit receive space conditioning system airflow either by use of a ductless space conditioning system indoor unit located on the wall, ceiling, or floor of the habitable space, or by use of space conditioning system air supply registers located in the habitable space that use ductwork connected from the register directly to the supply air outlet of a ducted space conditioning system air handling unit. Transfer fans that move air from one space in the dwelling to a different space in the dwelling, but do not heat or cool the air transferred, do not meet the requirement for providing space conditioning system airflow. When compliance requires verification that a wall-mounted thermostat has been installed to control a space conditioning system's indoor unit operation, the system's indoor unit thermostat shall be verified according to the following procedures. If a system has more than one indoor unit, then all of the system's indoor unit thermostats shall be verified according to this procedure. If the conditioned floor area of the zone served by an indoor unit is not a criteria for determining the compliance requirement for wall-mounted thermostats, then skip to subsection B. Otherwise, if the conditioned floor area of the zone served by an indoor unit is a criteria for determining the compliance requirements for wall-mounted thermostats in the zone, then record the conditioned floor area served by the indoor unit. If the zone area size criteria indicates that a wall-mounted thermostat is not required for the zone, then the indoor unit complies and no further thermostat verification is required for the zone served by the indoor unit. If the zone area size criteria indicates that a wall-mounted thermostat is required for the zone, then perform the remaining steps that follow. If possible, locate the wall-mounted thermostat that controls the indoor unit and verify whether or not the thermostat controls the indoor unit by setting the thermostat to a cooling set point that is less than the room temperature, or alternatively by setting the thermostat to a heating set point that is greater than the room temperature. If there is no wall-mounted thermostat installed in the zone that controls the indoor unit, then the indoor unit does not comply. If there is a wall-mounted thermostat installed that controls the indoor unit, but it is not located within the zone served by the indoor unit, then the indoor unit does not comply. For a wall-mounted thermostat installed in the zone that controls the indoor unit located in step B, by visual inspection determine if the thermostat is mounted permanently to the wall. Wall-mounted brackets or other means that facilitate non-permanent attachment of handheld thermostats to the wall do not meet this requirement. Non-continuous fan operation field verification. This is found in section SC 346. When compliance requires field verification that an installed space conditioning system indoor unit does not operate the air distribution fan during periods when the space does not require heating or cooling, the system's indoor unit operation shall be field verified according to the following procedures. If a system has more than one indoor unit, then all of the system's applicable indoor units shall be verified according to this procedure. If possible, locate the manufacturer's indoor unit plus outdoor unit combination in the Energy Commission listing of systems that have been certified by the manufacturer as systems that do not operate the air distribution fan during periods when the space does not require heating or cooling. So this is that same Excel spreadsheet that we looked at earlier with the yes/no column. Switch the system to heating mode, and then switch on the heating system by setting the thermostat to a set point that is greater than the room temperature. Verify the thermostat activates the indoor unit airflow, and then switch off the heating system by setting the thermostat to a set point that is less than the room temperature. Verify the indoor unit air circulation fan does not operate when the compressor is off, except for a fan overrun or fan off delay of less than 10 minutes that may occur at the end of the compressor on cycle. Switch the system to cooling mode, and then switch on the cooling system by setting the thermostat to a set point that is less than the room temperature. Verify that the thermostat activates the indoor unit airflow, and then switch off the cooling system by setting the thermostat to a set point that is greater than the room temperature. Again, verify the indoor unit air circulation fan does not operate the indoor fan when the compressor is off, except for a fan overrun of less than 10 minutes that may occur at the end of the compressor on cycle. So it's just a quick summary. You're going to turn the heating system on, make sure the fan only comes on when the heating system's on and then turns off once you turn it off, and do the same thing on the cooling cycle. You just want to verify that that fan only runs when it needs, when either the heating or the cooling system is actually running. Minimum airflow rate verification, and this is found in section SC 31422. So each new ducted indoor unit shall have airflow verified in accordance with the procedures in RA 3.3. So again, that's just your standard airflow verification that you do. For indoor units of single split systems, the measured value for airflow in CFM shall be converted into CFM per ton by dividing the measured indoor unit airflow rate by the nominal tons of the outdoor unit cooling capacity. For indoor units of multiple split systems, the measured value for airflow in CFM shall be converted into CFM per ton by dividing the measured indoor unit airflow rate by the nominal tons of indoor unit cooling capacity. So these are a little bit different. If it's just a single split, you're going to use the outdoor unit or the condenser cooling capacity. For multi-split systems, you're going to use the cooling capacity of the indoor unit, as the condenser is going to be a much larger capacity than that one indoor unit, and so it's not expected to have as much airflow as the outdoor unit. For heating only systems, the nominal air handler airflow shall be 21.7 CFM per 1000 BTU per hour of rated heating output capacity. Again, this is a similar calculation or formula that we use. Typically, we'll use it on calculating airflow for duct leakage. And then for cooling systems that are package systems or split systems with only one indoor unit, the nominal air handler airflow shall be 350 CFM per nominal ton of outdoor condensing unit cooling capacity. Otherwise, the heating only value, whichever is greater. For small duct high velocity systems, the nominal air handler airflow shall be 250 CFM per nominal ton of outdoor condensing unit cooling capacity. And then for multi-split systems that provide cooling, the nominal air handler airflow for each indoor unit shall be 350 CFM per nominal ton of indoor unit cooling capacity. Air filter sizing, section SC 3147. When compliance requires verification that a ducted system's indoor unit air filters have been sized in accordance with the maximum face velocity specification, the following procedure shall be used. Indoor unit design airflow rate. Record the design airflow rate for the indoor unit in CFM as specified by the system designer. The design airflow rate shall be equal to or greater than the minimum airflow rate required for compliance with the standards. Alternatively, if the design airflow rate for the indoor unit is not available, calculate and record the nominal air handler airflow rate for the indoor unit in accordance with the specifications in SC 31422. Air filter design airflow rate. For indoor units with only one filtered return air inlet, the air filter design airflow rate in CFM is equal to the indoor unit design airflow rate determined in Step A. For indoor units with more than one filtered return air inlet, the system designer shall determine what portion of the total indoor unit airflow is equal to the air filter design airflow for each air filter, ensuring that the sum total of all individual air filter design airflow rates is equal to the total indoor unit design airflow rate determined in Step A. So, summary on this, if you have more than one filter, each filter is going to flow a portion of the total target airflow. So if the total is 1,000 CFM, one filter might flow 400 CFM. That means that the other one needs to flow 600 CFM so that when totaled together, they're going to achieve that 1,000 CFM target. Air filter grill or rack sticker. Standard section 150.0M12B4 requires that air filter installation locations shall have the air filter design airflow rate and maximum allowable clean filter pressure drop at the design airflow rate posted on a label or sticker inside or near the location of the filter grill or rack, such that this information will be visible to a person replacing the air filter. So this is just the standard labeling requirement that is applicable to all ducted systems under the standards. Air filter maximum face velocity allowed. Record the maximum allowable face velocity value in feet per minute required for compliance for each air filter. Minimum air filter face area allowed. For each air filter, divide the air filter design airflow rate in cubic feet per minute by the maximum allowable face velocity in feet per minute. The result is the minimum allowable total air filter face area in square feet for the air filter. Convert the calculated face area from square feet to square inches by multiplying the face area in square feet by 144. Installed air filter nominal dimensions. Measure and record the installed nominal length dimension in inches and nominal width dimension in inches for the side of the filter that is perpendicular to the direction of the airflow through the air filter installed in the return air grill or rack of the indoor unit. If there is more than one filtered return air inlet for the indoor unit, measure and record the length dimension and width dimension of each of the air filters. Installed air filter face area. For each of the filtered return air inlets for the indoor unit, multiply the nominal air filter length dimension by the nominal air filter width dimension to calculate the nominal air filter face area in square inches. Determining compliance. For each of the filtered return air inlets for the indoor unit, if the installed air filter face area is greater than or equal to the minimum air filter face area allowed as determined in step E, then the air filter complies. All of the indoor unit air filters that are required be sized and verified according to a face velocity specification shall comply, otherwise the indoor unit does not comply. Air filter maximum pressure drop. This is found in SC 3148. When compliance requires field verification to confirm that a ducted system's indoor unit air filters comply with a minimum clean filter pressure drop requirement, the following steps shall be followed. When there is more than one filtered return air inlet for the indoor unit, all of the indoor unit's air filter devices shall be field verified. Indoor unit design airflow rate. Record the design airflow rate for the indoor unit in CFM as specified by the system designer. The design airflow rate shall be equal to or greater than the minimum airflow rate required for compliance with the standards. Alternatively, if the design airflow rate for the indoor unit is not available, calculate and record the nominal air handler airflow rate for the indoor unit in accordance with the specifications in SC 31422. Air filter design airflow rate. For indoor units with only one filtered return air inlet, the air filter design airflow rate in CFM is equal to the indoor unit design airflow rate determined in step A. For indoor units with more than one filtered return air inlet, the system designer shall determine what portion of the total indoor unit airflow is equal to the air filter design airflow for each air filter, ensuring that the sum total of all individual air filter design airflow rates is equal to the total indoor unit design airflow rate determined in step A. Air filter grill or rack sticker. Standard section 150.0M12B4 requires that air filter installation locations shall have the air filter design airflow rate and maximum allowable clean filter pressure drop at the design airflow rate posted on a label or sticker inside or near the location of the filter grill rack, such that this information will be visible to a person replacing the air filter. Air filter manufacturer's performance rating label. Standard Section 150.0 M12E requires that the air filter placed in the filter grill or rack shall be labeled by the air filter manufacturer to disclose the clean filter pressure drop performance determined according to ASHRAE Standard 52.2 or AHRI Standard 680. The required air filter label information includes clean filter pressure drop ratings at a range of airflow rates. Determining clean filter pressure drop compliance. Inspection of the air filter manufacturer's performance rating label shall verify that the air filter is rated to provide a clean filter pressure drop less than or equal to the value required for compliance at an airflow greater than or equal to the design airflow for the filter. Interpolation of the manufacturer's airflow and pressure drop rating values published on the air filter performance rating label is allowed when determining compliance. Field diagnostic pressure measurements of operating indoor units to determine the pressure drop of installed air filters are not required for demonstrating compliance. The form that will be used to document the variable capacity heat pump compliance credit is the CF3R MEC 33, and it is 5 pages long. Should you have questions about this training, you may contact us at 1-800-424-3377, or you can send an email to adminsupport@cheers.org.